Hello, friends, and welcome to this new and a fresh lecture of mathematics here. I already introduced you that how we can study and start this course of mathematics with great comfort and what is the order that we'll find logical to study the subject. But I also reminded you that most of the people who actually do very well in mathematics and who are very spontaneous and enthusiasts, as we say them, are people who are very interested in patterns in mathematics, do not really like to involve them into any structure or any logical or so-called fixed path of study. They very they are very much likely to follow an in-ordered study routine, and that is how geniuses and brilliant minds are made. They do not find order, they are accepting the reality of this universe and its beautiful patterns as it comes to them, and they are so curious. So I will recommend you also to do not be too strict about the order, but if you are merely here for seeking the theoretical part or having any burden of examination to complete the syllabus, then the understanding is better if you go by logic and order. But as far as the interest and the learning aptitude is concerned, the natural order of unfolding the patterns of mathematics is the most beautiful one. So, expanding and extending our discussions on the subject, as I already told you, that discrete mathematics and mathematical proofs is the section which is very good to start with. So I'm starting with here at the topic of intuitive proofs, and I hope that you all people will like and love it. So let me introduce it with a quotation by Douglas Adams, and he wrote in his book The Hitchhiker's Guides to the Galaxy. He wrote, "The history of every major galactic civilization tends to pass through three distinct and recognizable phases." And what are those phases? Those of survival, inquiry, and sophistication. You must understand that survival, inquiry, and sophistication, these are the words, but how do we identify them in our day-to-day lives is as how, why, and where phases of our development, whether in the subject of mathematics or in our civilization, whatever you can assume. For instance, the first phase is characterized by the question, how can we eat? The second by the question, why do we eat? And the third by the question, where shall we have lunch? So once we are sorted out with the questions of how and why, we can explore new dimensions to it, right? And this is one of my favorite quotes about this. So coming to the topic, your mathematics education will also pass, as Douglas Adams stated in his book, through these three phases, that of survival, inquiry, and sophistication. That means how, why, and where or what next, right? The first phase is characterized by the question, how can I solve this integral? The second phase, by the question, why does my solution work? And the third phase by the question, where should we explore next? So indeed, your previous phase 1, math classes that is about how and about the methods, how to solve this integral and how to solve this mathematical problem, were probably focused on computation, like methods and how do you compute to get to the answer, like how to use the fundamental theorem of calculus to solve a problem. In your future phase 2 math classes, you will seek to understand why the fundamental theorem of calculus is true. When your curiosities guide you to seek out new math and pursue your own original ideas, perhaps by engaging in mathematical research, you will enter phase 3. And this is the phase of research, where and what next. And you will explore much more on this path than you have ever studied or in the previous 2 phases of your study in mathematics or elsewhere in life. When you start researching, then you open up the dimensions that were unexplored, and you find it very astonishing and deep fulfillment and awe in your heart. Like in your earlier phase 1, that is the how phase, math courses, you were taught to use the quadratic formula to solve the second degree polynomials, right? The quadratic polynomials, to find its roots, to find its zeros of the polynomial or the roots of the polynomial equation, you were taught. In a future phase 2 math courses, you learn that there are similar formulas for third and fourth degree polynomials, and that is why we generalized the case and we took a deeper insight to like that how that formula for quadratic formula for solving a quadratic polynomial comes, second degree polynomials, where does it come from? But not for the fifth degree polynomial. Like you will learn similar formula for third, fourth, but not for the fifth degree polynomial. And then you ask, where do we study this fifth degree polynomials? We want to extend, and we ask the questions where and what next, and you will see precisely why that is the case. Your future courses will also introduce you to lots of topics that did not appear at all in your previous courses. In fact, I think the most interesting math topics are saved entirely for second phase courses. So you have a lot to look forward to. And in this course is the gateway. Like this is a course on proofs, and this you can understand as a gateway to phase 2. And phase 2 is just mind-blowing and so much of fun and exploration. You will like it. And just stay tuned and be excited. It will show you the techniques and that mathematicians use to understand our math, which we call proof techniques. And it will introduce you to new math topics that you will explore in detail in your future courses. So buckle up, because math is about to get a lot more interesting. So this is all what I had to talk about in this specific video, and see you, my friends, in a later video. Up until then, wait for me and love mathematics and keep exploring new things in mathematics. And I'm always here to help you, guide you, and love you. So that is all for this one. I will look you and meet you in the next one.